All right, good morning, everybody. Happy Tuesday. Hope you all had a good weekend, taking advantage of this time to get some stuff done. We're going to start off with a quick agenda, a quick rundown of things I want to specifically talk about, and then we'll move into our final section in this unit where we wrap up all of our knowledge on logarithms and exponential functions and talk about how we can solve exponential equations with logarithms. Kind of the final icing on the cake and also what's to be expected this week. But first, sorry, just some quick announcements. Can everyone see the announcements on my screen? It's portraying like the top third left-hand corner is cut off. Is that the same issue for you all as well? Okay, I don't know why it does that. And of course I can't go backwards, but for some reason it does it every now and then. Okay, so our announcements, today, or rather this week, is our last week before spring break. So I'm kind of actually jumping to number 5 here on the screen. But because of that, I have a bunch of assignments that were due on the 3rd, which is this Friday. So all of the ed puzzles that have been assigned thus far, all the ones on the changing the base, the properties of logarithms, the exponential and logarithmic equations, all of those are due by this Friday. A lot of you have been doing a very good job on those. I just wanted to kind of reiterate that so that way we are aware of what's due and when it's due. Also, everything on this unit, lessons 14 through 18, and the quizzes due this Friday. The quizzes is taking place of the lesson 19 homework, what we're going to be talking about today. So please make sure you get that done as well. Cool. Any questions on when things are due? Also, heads up, if you have any needs, if you need some extensions, never hesitate to contact me. I would be happy to help you out. I'm very flexible in this time, so just talk to me and we'll get what you need done. Right on. Hold on one second here. Can you hear me right now? Because I just was notified that I cut out. Cool. Okay. Awesome. Thank you for letting me know that. For the homework, do we take pictures and send it to the Google Classroom? Yes. Yeah. Take pictures and send it to the Google Classroom, or rather, not necessarily send, but the proper word would be to upload to the Google Classroom in the proper links. So yeah, great questions, y'all. Thank you for asking those. Awesome. So the remote learning agenda, I say here, use the new one, and the new one is this Google Sheets. The original one that I sent out was a document, and it had all those links to it, which was super useful, but then I adjusted it when I found out that our remote learning time was going to be extended through May, or rather through the end of April, early May. So I made this new remote learning agenda, and this one is your best friend in the terms of what we're doing on which day and the pacing and when the due dates are. So please use this one moving forward, not the document one. I actually unshared the original one. If you kind of understand what I'm talking about, the original one, the original one looked a little something like this. Give me 1 second as I locate it. This one. I've basically discontinued use of this one. Okay, it is the same thing as the Sheets version. This one currently that you see on the screen is now up to date, so please use this one going forward. It's really the only one that you'll have access to. It just tells you what we're doing and when the assignments are due. All right. Okay, the comprehensive review assignment. I've had a couple people start on this and complete it. Well done. You do not need to do this until, or it's not officially due until 2 weeks from Friday, the 17th. So there's still a lot of time to do it. I want you to utilize edits and resubmits on this, meaning there's 3 of you who have completed this right now. I'm going to release your scores this afternoon. If you don't get 100% on it, I want you to go back and try it again. It's kind of our not yet grading type of thing where it says I'm cutting out again. I think it just might be a connection issue, so I'm very sorry about that. Unfortunately, my bandwidth isn't great here. Am I good? Everyone hear me again now? Okay, cool. Please, on this comprehensive review assignment, number 3, please use edits and resubmit, ask me questions. It's not due till the 17th, but we will be going over a few of those questions this upcoming Thursday because it's our review lesson. It is, it's just, sorry, I'm reading the comments too. Sorry, my brain went off track. But it's basically our review of the entire unit. So the questions are going to be a little bit harder. So I'll go over a few of those questions on Thursday, but I'll also be happy to answer any questions that you may have. which takes me to number 4. Use the RLQs, the remote learning questionnaires. Those are those Google forms that you all been filling out. You've been doing a great job doing so. They look a little something like this. Keeping in mind, everyone, that this is currently up on, oh nice, already 2 of you already put responses on there, right on. It doesn't look like it's loading on my screen yet for some reason, which is weird, but I can see it on my iPad, but y'all can't see it in front of you. These are the Google Forms. Again, not loading from what I could see via Zoom, but loading here on my screen. I don't know why Zoom is not working right now. Let's see. Serious technical difficulties today. My screen is frozen. Sweet. Cool. Bear with me 1 minute. I have to log back in. My screen share froze. So sorry about that. Not the smoothest start to today's class, that's for sure. All right, 3, 2, 1. Hopefully my iPad, right on, we're back up. Okay, so what I was saying, or what I was trying to say was, fill out these RLQs, which you should now see popping on the screen. These things. Right on. Make sure to continue filling those out. A lot of you have been doing so, so I do appreciate that. Always feel free to ask me questions. Trying to be flexible and available to help y'all here. All right, cool. And again, last but not least, spring break is next week, so we can all take a little time off. I know we're not really going anywhere or doing anything extravagant due to the current situation, but at least we won't have to do math or do work at that time, so that's gonna be a good thing. All right, does anyone have any questions other than the technical difficulties that kind of we've been running into in terms of me cutting out and whatnot? But does anyone have any questions on the announcements, what's expected to be due, and or where we could find all that information on the Google Classroom and remote learning agenda? If you do, feel free to unmute yourself or ask me a question in the chat box right now. If not, I'm going to cruise into today's lesson.
Mr. B, what did you say about taking pictures for the homework?
Okay, yeah, great question. So when it comes to submitting the homework, classroom, right on. We go to the classwork section, and then basically you can find, right now we're finishing up module 6 this week, but find whatever lesson you want to submit. So let's say we wanted to submit lesson 14. Take the pictures of your work. In this case, the assignment that was lesson 14 was pages, gosh, of course, this doesn't want to load very quick, 190 to 192. So pick those 3 pictures of those 3 pages, page 190, 191, and 192, and then go to the Google Classroom and then upload those pictures through the use of that paperclip icon. So anytime you want to upload anything, everything that you should be needing to upload should be visible and present on the Google Classroom under the classwork section. And then to upload those, make sure you submit those pictures or upload those pictures to submit your assignment. Does that answer your question? I'll take the silence as a yes.
Yes,
Yeah,
sorry,
okay.
thank you.
Yeah, no worries, no worries. Okay, cool. All right, any other questions before we jump into the kind of consolidated summary lesson for this entire unit, which is lesson 19, what we're about to jump into? Sweet. By the way, I do want to say I appreciate y'all being here. I know a lot of you have been continually being here every single lesson, so that is much appreciated. Not only does it make me feel good, but it also helps out with this learning process. Okay, so lesson 19, exponential equations. We actually had an entire unit on this, flashback to when we did those compound and continuously compounded interest problems. We had that kind of 6 or 7 question test right about a week or so before we left for remote learning. And we're going to kind of tackle all of that, well-round all of that today with our knowledge now of logs, because we know logs answer exponential knowns. So today we're combining our abilities of solving equations, classic algebra problems, isolating the variable and solving for it, now with our knowledge of what logs are and exponential functions into one skill. Now we're going to be starting off in our text on page 255, and then we're going to go over some problems that you see there in the purple section, 256 numbers 1 and 4, 260 numbers 14 and 15. Also, you kind of see over there on the right side in the gold what we already talked about in the announcements. Make sure you get those assignments done. So let's stop being long-winded about this and let's get right into today's material. Again, this is on page 255, and I want to start off with a quick question. If you have the answer to this, and I know this is one of our first times that I've been asking questions in terms of asking y'all to answer this since we've gone to remote learning. But if you know the answer to this question, how did we solve exponential equations before we learned about logs? Please either unmute yourself or type it into the group chat. Give about 15 seconds here to see if anyone knows or recalls how we solved exponential equations before we knew about logarithms. So this brings back fond memories, huh? Like instead of me just wandering the classroom aimlessly, now I just get to sit here and ask you questions. What? Andrew, welcome. Andrew, you're in Algebra 2 Trig right now, man. So you haven't learned about logs yet. So Algebra 1 is going to start at 11:15. So I'll see you then, man, unless you want to stick around, but you don't know logs yet. Anyone in Algebra 2 Trig remember how we solve exponential equations? All right, I'll give you a hint. What we did is we set the bases to be the same. So I kind of had that zoomed in here on page 255 because what we're going to learn today when we're solving exponential equations, and by the way, those of you who've done the Edpuzzle on this have done a good job so far, a lot of really good correct answers on that Edpuzzle. But when we're trying to solve exponential equations, we always wanted to get the same base, okay? And what we're looking at here on page 255 in example number 1 is a situation or an equation where we actually have that capability really easily. Again, this is on page 255, where we have numbers like 4 and 64 that can be turned into the same base. Well, 4 is already a base of 4, and then we just turn 64 itself into 4 to the third. And what I'm talking about here by this same base kind of mumbo jumbo is these numbers down here. Those are both 4s. So we learned in the exponential unit that once we've achieved an equation where the bases are the same, we could focus on solving the exponents. Okay, because we already knew that these two things are super close to being equal, except for those red exponents are not. So we change the bases to be the same, we work with the exponents, and we solve. Now that we've talked about logarithms, we have a second option when we're solving for exponential unknowns, and that's to take a log of both sides. Logs, they answer for exponents, so they answer exponential equations. Probably should have wrote the answer first. They answer exponential questions, so therefore we can leverage or use logarithms to our advantage to solve for exponential unknowns. Now, a heads up, what we're going to be talking about on Thursday. So whether you're here right now or you're watching this recording, please try to tune in on Thursday because we're going to be going over that comprehensive review assignment. And a lot of these tactics that we're talking about right now are going to be put into word problem form at that time. But not a word problem, just a standard equation. We have two numbers, 4 and 6, who are not easily turned into the same base. Like we can't turn 6 into 4 to some power very easily. So option number 1 of rewriting with the same base up here towards the top of the screen is not going to be as good for the example number 2. So what we're going to do here is we're going to take the log of both sides. And that's what we see being executed in our second option. AKA, when you can't turn the bases to be the same, 4 and 6, not conducive, not able to be done, log both sides. And when we log both sides, what we're then using is our different rules or properties for logarithms. Specifically in this case, we're going to use the power property, which states that if we log an argument like 4 has an exponent x plus 2, we could take it down and drop it in front and call it a multiplication of that log. That was our power property of logarithms. Again, when we have an exponent of a logarithm, as we do here, 4 to the power of x plus 2, we drop that x plus 2 down in front. And now from here on out, it's kind of a weird looking form of Algebra 1 properties, but everything about to be highlighted in purple, that's all kind of secondhand knowledge of solving with Algebra 1 skills, meaning the first thing that we did here in this portion is we distributed x times log 4 and 2 times log 4. We use the distributive property to get from row 3 to row 4 distributed. And then all that we were doing is we're working towards isolating x here by subtracting 2 log 4 on both sides. And then the last thing that x needs to be done is to get rid of the multiplication of log 4, which means we divide both sides by log 4. So it really is kind of an extension of a lot of the concepts that we've talked about, both in Algebra 1 and in this class now, specifically using these properties of logarithms right up here. But we're really looking to isolate x to then leverage a calculator in this humongous problem right there to get our actual final answer. So that's kind of where we're trending for today. Let's get into a few problems that might be a little bit easier than this one. And let's cruise on down to the next page. 256, number 1. All right, first thing that I notice here on page 256, number 1, is my unknown is an x. It's our variable right there. It's buried up inside the exponent, or up in the exponent. So that means to solve for an exponential unknown, I'm going to probably have to use a log here at some point, but we'll see. Another thing that I notice is that this x plus 3 is attached to the base of 5, which means that 2 is just a multiplication problem. So I'm going to get rid of that 2 by dividing everything on both sides by 2. Very first step, get rid of multiplication, start to work towards isolating the x. In this case, the x is in the exponent, so I really just want to get that base of 5 by itself. And when I divide by 2, I now get 5 to the x plus 3 is equal to 6,250 divided by 2 is 3,125. Okay, now there's 2 steps that we could do. By dividing by 2, we've turned it into this kind of Christmas colory problem. We could try to do 2 things. We could either try to change these 2 numbers, 5 and 3,125, into the same base, or step number 2 is we could try to use logarithms to our advantage. So I personally, since we are starting to use logarithms and we now know that a common log, a log base 10, can be solved with a calculator, I think it's more efficient to try to use logarithms on both sides. So what I'm going to do is I'm going to actually rewrite this problem just directly beneath it here. And I'm going to log both sides, meaning literally when I log both sides, it's as easy as script-wise, writing-wise, writing a log out in front. Now what I've done here is I have taken the ability and I'm going to copy and paste the right side of this equation, because that right there, log 3125, that's straight up a calculator problem. We're going to save that till the end because it's just pushing buttons. What I do need to do on the other hand though is work with the left side of my equation. Let me kind of cue up my blue here, and I'm going to use my power property. And that's because I'm taking the common log, log base 10, of the argument 5, but I'm raising that argument 5 to the x plus 3 power. So now what I'm about to do in blue is I'm going to execute that power property of logs, which states that I can drop down that exponent, that power, x plus 3, and you turn it into a multiplication problem of log of 5. So flashback to lesson 15 when we learned about those 5 properties of logarithms. We kind of cruised through them right before we went to remote learning, and some of our ed puzzles and work since then have been kind of reiterating those properties. But these properties you now see come in handy, not necessarily for standalone problems, but they come in handy here as we solve our exponential unknowns with our logarithm exactly. So now all I've done is I've gotten a lot closer to solving down this problem. I have x plus 3 times log 5. All I'm going to do is divide both sides by log 5. And the reason why I'm doing that is because I'm working towards isolating that blue x step by step. And now as I do so, we're getting much closer to an isolated x value. Notice that when I divided both sides by log 5, I just have x plus 3 on the left side of my equation. And now all I got to do is get rid of that plus 3 by subtracting 3 on both sides. Whoa, my writing is not really ever that good, but it's particularly bad right now. Okay, I subtract 3 on both sides because when I do so, 3 minus 3 is gone, and look what I've done. I've succeeded in isolating my x value. Now, you might be thinking to yourself, well, that answer x equals log 3,125 divided by log 5 minus 3 is no good. I agree with you. So what I'm going to do is I'm going to just use my calculator now and evaluate everything that I'm circling in blue. I'm literally going to type that exact thing into the calculator. So we have log of 3,125 divided by, I believe it was log of 5. Let me just double check that. Yep. So log of 3,125 divided by log of 5. Notice I've moved to the right of the fraction. Now I'm going to hit minus 3. And again, what you see now in the calculator is just a direct replication or a mirror image of what we saw on the page 256, number 1. Did all of that division, now subtraction, and we get that our answer is x equals 2. So when I plugged all of that blue circle into the calculator, they gave me a 2. Now that was a long process to solve one problem because number 1 was kind of lengthy. I'm going to go through the steps one more time before we move on to number 4. I divided by 2 first. The reason I did so is to get rid of this multiplication of 2. Then I had this Christmas colored problem right here. Right on. Then I exercised or used the power property of logarithms shown in blue here, where I took this power x plus 3 after I logged both sides shown in purple, and I brought that power down in front because we know that when we raise an argument to an exponent, it can be moved into a multiplication problem. And then I started to work backwards, just getting rid of multiplication of log 5 by dividing by log 5 on both sides. And then I got rid of this x plus 3, which used to be right here, by subtracting 3 on both sides. And when I did so, we just had x was equal to this calculator problem, which returned us to 2. All right, let's do number 4 then, and then I'll open up to some questions here because we're making pretty long time on this one. Now I'm going to do number 4, page 256 again. You notice I already started off by logging both sides. Again, turning 4 and 32 into the same base is doable. 4 is 2 squared, 32 is 2 to the 5th. Not ideal. Once we know what logarithms are, we can log to solve for exponential unknowns, and after all, that is what we're looking for here, an unknown, x, an exponent. So I log both sides, and then when I log both sides, I'm going to reuse my product property, which states the following. I take my exponent, blue, 3x minus 1. Since that's being raised, 4 is being raised to that power, I could take that exponent and multiply it by log of 4. Trying to make some quick work here. Boom. Okay. Now all that I'm doing again is solving for x. Notice x has a lot of things going on with it right now. So first thing I'm going to do is I'm going to get rid of this log of 4 by dividing both sides by log 4. Slowly but surely kind of like chipping away at the x, which then leaves us with, by the way, this is gone now, log 4 and log 4 are gone. Leaves us with just that 3x minus 1 on the left side of our equation. And that's equal to, I'll save this log 32 divided by log 4 for the end. That's going to be calculator work at some point. Okay. Boom. There we are. Now I'm going to add 1 to both sides. And once I do so, it looks long and it looks intimidating, and it might be long and intimidating, but it's purely calculator work on the right side of our equal sign right now. My focus is just basically on undoing the left side. So just so it doesn't look too crazy, I'm actually going to evaluate all of this on the right side right now in orange. I'm going to take that into a calculator. So here we go. Log of 32 divided by log of 4. And then I was, I believe, adding 1 to it. So I hit plus 1 on the right side of the fraction, and we get 3.5. So really where we're at now is that once we used a calculator to evaluate, aka to solve the right side of the equation, we got 3.5. Now all we got to do is isolate x by dividing both sides by 3. And then we'll get x is equal to 3.5 divided by 3. I'll move back to that in 1 second. 3.5 divided by 3 is about 1.16 repeating. So we used a calculator here. We got 1.16 repeating, or x is approximately 1.17. Either of those will do. All right, let me zoom out real quick so we can see the process. Does anyone have any questions on numbers 1 or 4? We have about 4 minutes left in class, maybe a little bit longer actually, because these problems take a little bit of time. No one has any questions on these? Do we feel like they're at least possible based on what we've seen before, kind of our combinations of properties of logs and our knowledge of solving for equations by isolating variables? I got a question. So if there's a number with x, we divide. Yeah, like that's a great question. So like this last problem, when we had this number right here, since that number 3 is with x, there's no visible operation sign in between, like nothing between the two right there. Sorry, circle makes it look like a 0. Nothing between those, it implies multiplication. So yeah, to get rid of that multiplication, division is the best answer. Great question. All right, then we're gonna try to do one more. And for this problem, I'm going to actually zoom on down to number 13. And just a heads up, y'all, due to limited time, I didn't get to numbers 11 and, sorry, we're gonna do number 14. I didn't get to numbers 11 and 15, so I will be recording individual videos for those as well. So you may check those out if you would like to, okay? I know it's a lot of videos to be watching, but please feel free to reference those or ask me questions on any other problem. All right, here we go. Number 14, let's go rapid fire here. First thing I'm looking for is I'm trying to find that x. X is having a lot of things happening to it. It's being subtracted by 1. That whole expression x minus 1 is an exponent, aka we're going to probably use a logarithm, and this whole thing is being multiplied by 10. So I'm actually going to work in the process basically of what I just said, but in reverse. I'm going to get rid of multiplication via division. Boom, divide both sides by 10. We're off and we're running. Okay, when we divide both sides by 10, 75 divided by 10 is 7.5, and that's equal to 5 to the x minus 1. All right, next thing I'm going to do is that since these two numbers, 5 and 7.5, are not easily turned into the same base, I'm going to use logarithms to my advantage, and I'm going to log both sides. You can natural log both sides too, aka ln both sides. I always just work with common logs. I don't know, just kind of my preset thing. So I'm going to log both sides, meaning I'm going to log the right side, and then if I log one side, property of equality says I got to log the left side. Now what I've done here, y'all, is I've turned this left side into a straight calculator problem, okay? Calculator problem. All right, you get the idea, terrible drawing and all. Now, what we haven't done is we haven't turned the rest of the problem into a calculator problem, and the reason why we have not done that is because we haven't leveraged the power property of logarithms yet, which states that this x minus 1 is an exponent, so I'm going to bring it down in front, x minus 1, and multiply it by that log of 5. That is what the power property of logs always tells us, is that we can always do that when we have a power above an argument, like argument of 5 to the x minus 1 power, bring it down. Sweet. Now, what we have done is we have basically finished the hard part of this problem, because now all we got to do is start working to get that red x minus 1 by itself. I'm going to do so by undoing the multiplication of log 5 via its inverse. So I'm going to divide both sides by log 5, because now guess what? That log 5 is gone, leaving me with just x minus 1 on the right side, which is always a beautiful thing to see because that means we know we're almost done. X is almost isolated. And now all I got to do is add 1 to both sides, because when I add 1 to the right side, these two are gone, leaving me with just an x. And now I know exactly what x is equal to. So x in this case is going to be equal to 1 plus the quotient of log 7.5 divided by log 5, which, as you might have guessed, is a straight calculator problem at this point. 1 plus the log of 7.5 divided by the log of 5. And y'all notice hopefully that on this calculator screen that you see, I have the 1 in front, and then I have log 7.5 divided by log 5 as its own fraction. I'm not dividing the entire expression by log 5, meaning I'm not dividing that 1 by log 5, just 1 plus the division problem or the fraction. Now what I'm going to do is follow the directions on the screen, and it said to round it to 4 decimal places. So my 4 decimal places are going to be 2.2519, as you can see in the bottom right hand side of my calculator screen, 2.2519. All right, there's number 14 worked out in entirety. And that's gonna be the last problem that we're going to do for today. But if you have any questions, please do not hesitate to either ask now, email me, fill out that RLQ, that remote learning questionnaire, this thing. Again, already 2 of you have already done so great job, thank you. I'll try to get those answered ASAP. And also what I'll do this afternoon, probably sometime after lunch for me, around maybe 1:30ish, I'll get number 15 done on the same page, and then I'll do the dreaded word problem of number 11, okay? If you don't have any more questions, we're gonna kind of wrap it up here for today. Hopefully you all have a great day. I do miss seeing you all. I know I say that every time, but I do. And I appreciate you all coming in and working hard as you always do. So if there's no questions, y'all can take off, and I'll see you on Thursday, okay? All right, y'all. Have a great day. Be safe. Stay healthy. You're welcome. Thank you.
So they couldn't get on at all.